Welcome to EDU World Space.
Okay, in this problem we have two springs. We have a mainspring, that's spring A, and a smaller spring, or a fusee, which is spring B. We're told that spring A can develop a torque moment, or TS, and this is given by the expression TS is equal to K theta. And K, or the torsional stiffness, is 0.015 Newton meters per radian. We're also told that the torque F developed by the fusee, or the smaller spring B, is always constant. Okay, so TF constant, we'll just write that out. Okay, so we're given a scenario where theta is 4 radians and the radius of the fusee is 10 millimeters. All right, so we'll say R is equal to, and write this out as meters, so 0.01 meters. Okay, so now we have to determine the required radius of the fusee when theta is 3 radians. Okay, so to do that, we have to make use of the fact that TF is always going to be constant. We can determine TF by the force, or the tension along this line, because the tension that's generated, or the torque moment that we experience on spring A, is going to also be applied to spring B. So let's find TS first. TS in this situation is 0.015 times, and here our theta is 4 radians. All right, so TS very simply is 0.06, and our unit here is Newton meters. Next, we also know that TS, like the torque, is given by the force times distance, or the radius here. So we know that we can substitute TS for the 0.6, which we just calculated, equals some force, and our distance, or our radius, for spring A is 12 millimeters, and it just tells us that. And that's 0.012 in meters. So F is going to be 5 newtons. Right. Now that we have F, we can determine TF, because TF similarly is going to be given by the force times the distance, or the radius. And since, as I said earlier, the force that the spring A is generating is going to be applied to spring B, we can determine that TF is equal to 5 newtons times, and in this problem we're also, in this scenario at least, we're told that X is 0.01 meters. 0.01. So we determine that TF, these F's are a little sloppy. You write a better one. This is legible. TF is 0.05 Newton meters. Okay, and remember, TF is constant. So in our second scenario, I'm just going to kind of separate this. In our second scenario, theta is 3 radians, and we have to find R, the radius of spring B. Okay, because we have theta, we can just find TS immediately, because it really only depends on theta. So TS is equal to 0.015 times 3, and that's 0.045 Newton meters. Newton meters. All right. Next, with the same logic that we used last time, we can find the force with TS. And here, the radius of A is 0.012 meters. And we determined that the force is 3.75 newtons. And if that force is 3.75 newtons, then TF, or then we can find the radius of TF, right? Because in this expression right here, we have two of these values, and we just need D, or the radius. So substitute those. And we'll say that's R. And here we determine, just by simple algebra, R is equal to 0.013, 3 repeating meters, or 13.3 millimeters. And that is our final answer.